Now I will discuss the new topic, that is magnetic bottling. Firstly, what is magnetic bottling? Basically, if we want to capture high temperature zone or very hot particle of the hydrogen, which are generally in plasma state, then we can capture these high temperature particle, plasma particle, in the magnetic bottling. Okay, so first of all of you know the magnetic field line due to solenoid is like this, which I have drawn here. Now I want to ask you to draw the magnetic field line pattern due to the two closely placed solenoid, means one more solenoid if I put near to this coil like this, and current is flowing in the same direction. You have to plot the magnetic field pattern. So what type of pattern you will get? Let me show you on the next slide, like this. Now this is good concept to explain the magnetic bottling. Basically this is the one of the example of the magnetic bottling, how we can store the plasma. So there are two current carrying solenoids and magnetic field pattern is like this. Now suppose I name there are three zone P, Q, R in this empty region between two solenoid. Now I think it is visible to all of you, at P point magnetic field is stronger, at Q point magnetic field is weaker, and again at R point it is stronger. Okay, so in this magnetic bottle we are using two solenoid, we flow the current and we observe the magnetic field pattern like this. Okay, so in this empty region we release a plasma positive charge particle, and when the plasma positive charge particle enter in the magnetic field region, it trap into the region and started to move, and that positive charge particle will move to the weak magnetic field region. Suppose you release the particle here, it will move from P to Q like this. So okay, if due to inertia this particle move from Q to R region, again at the R region it get the strong magnetic field, again it is reflect back. So let me draw, it is reflect back. Again due to inertia it is moving from Q to P side, again it is giving high magnetic field, it will move to the Q region because Q region is in the low magnetic field region. So in the next video lecture I will discuss why this charged particle has a tendency to move to the weak magnetic field region. That I will discuss when I will discuss the diamagnetic, paramagnetic, ferromagnetic substance, then you will get in better way. But at this time you take my word, if I release the plasma, it has to move to the weak magnetic field region. In this way this plasma will trap here. Okay, so in this region we can put the high temperature particles, which are the hydrogen ion, and if temperature is very high, we can create helium from hydrogen also. Hydrogen can be converted into the helium, fusion reaction may be possible here. So this is the magnetic bottling which I want to explain you. So let me show you one sample on the next slide, like this. So you can understand this particle has a tendency to move in this region like this. This is the hot plasma, which yellow shaded zone, which is visible to you. Okay, now I will give you one video animation so you will get in better way. So this is the animation, this is the charged particle which is trapped and it is moving from weak to high, again it is reflected to the weak magnetic field zone and it is trapped in this region, that is a magnetic bottling.